So if you're watching this presentation for the first time and you have not seen template programming elements and template programming in your experience, if you're watching this video for the first time and you don't have any experience programming C++ templates, I am sure that you're becoming a little bit frustrated with the amount of new syntax elements and the level of abstraction that you need to kind of comprehend and embrace all of the situations where we're using these templates. Of course, everything comes with experience, so I think I recommend that you watch these videos a couple of times and make sure that you dig through all of the handouts that I specified on the reading list for this week. But also, the good news is that I'm not asking you to start programming templates right away, like basically become a template guru. It would easily require another course, the entire full semester course, to cover every aspect and every technicality of a template programming and go through multiple scenarios of various situations where templates are used. So anyways, this is a huge part of C++. Template programming is basically an advanced set of features built into C++ programming language, and I would encourage you to first design simple classes, not template classes, and if you're tempted to try converting them to a template, just the same way as our story began today with container. First it was a container of an integer, and then we decided to try some interesting things, and all of a sudden this code became, this much long, and all of this effort so far is actually visible. It becomes beneficial to this side of the code, our main function or our client side. So right here, the user of the container class really starts using it in a very, very convenient way, and everything just works, and you can use different data types to plug them in as container element type. Anyway, so this is just a general observation, so don't expect to memorize all of this, and you would have to watch it a few times and go and dig in through all the handouts and tutorials and possibly other books. So we're going to continue with our presentation. There's some highlights here that you need to be aware of, so I am not going to spend much time reading these things to you. I assume that you can basically read these tips and highlights of templates, and it's just an explanation of what we have already discussed, for example, with the syntax of using an expression like this, which is using a constructor syntax with some data type and default constructor. Okay, so I'm just going to fast forward this, and again, this is what I refer to as a template trick. Really, it's just a part of the C++ syntax to make every type invoke default constructor for every type. Okay, so for primitive data types such as int, syntax will return 0. You can try this and print this on your console screen and see if it returns 0, and I can assure you it will return back a 0. Alright, so it's just basically another example where the syntax is used. So this example that we have is describing a class template, and it's named container in our case. With function templates, so you can have the same thing. I mean, basically, we already had this function, which is a template in our case. But if you think about functions such as find maximum value, so this max int is hard-coded to use integer parameters, compare the two parameters, and return the bigger one. Okay, but if you'd like, you can make such function a template. And here I no longer call it max int, I call it max value. And what do we do here? We just pass out from this function a reference to one of these things. And you can see that, again, we're just trying to compare these things and select one or the other. But this time, the function itself becomes a template function. So this is a template function. So classes can be templates and functions can be also templates in C++. By the way, these topics, of course, are discussed in this in a very nice level of detail in learncpp.com series of tutorials. This is chapter 13 of the tutorial that I would encourage you to keep reading when you have time. Okay, so this is max val being put into action. I'm not going to copy and paste this example, but you can observe that, for instance, we're trying to use this max val with two strings, hello and bye. And we're trying to select the string which is a bigger one. And we pass two of these functions as parameters. And if you copy and paste, you should find out which one it will be printing. Okay, so which one of these it will be printing. As you know, strings can be compared by greater than and less than operators. So the string has these operators overloaded, and of course, because H alphabetically occurs later in the alphabet, then hello will be greater than bye. That's why it prints hello and not the other one. Templates and a friend, this was part of our discussion in our previous video. So this is somewhat similar to what we already have, and it just highlights all of the steps that we discussed in our previous video. So we have a separate slide, and you should be able to match this version of a templated version of this operator in the sample code that matches number 11, this slide number 11. Other interesting information is that we're going to discuss inheritance in the future, C++ inheritance, which establishes a relationship between classes. So a lot of things can be solved with inheritance, and a lot of things can be solved with templates. So perhaps we will come back to this discussion when we're talking about inheritance. So once again, these are just some tips and some highlights that you can read and try to come back to these topics when we cover both templates and inheritance in our course. And in terms of the philosophy, I always find it really a very successful way is that sometimes it's just a little bit too overwhelming to think about some concept and instantly make it a fully functional, fully featured template. You can see that it's a tedious process, and we kind of trying to build up layer upon layer upon layer, deciding about little details. So this I really recommend you to remember. If you ever have a challenge to design a template library or template class or set of template functions, really just implement concrete non-template version first, right? Just a simple version. And then what you do is you start adding this to the declaration or definition of your concrete versions of the code and replace, like we did here with integers, replace your integers or some other data types with the template version of them. And of course, the advantage of having this is that you still have the same concept. Remember that before compiler really implements all the code, generates all the code, it has to resolve every value type. In our case, it's a value type, and replace it with real type that we supply when we create our container objects. So therefore, you should be able to design same concept based on your integers or strings or some other data types and fully test it. And only when you're really comfortable with the tested version of a concrete non-template version of your class or function or library of classes, then you can transition to conversion to the template version. So this really is a great tip to know about template programming, that every template library or class or something that uses template syntax really usually originates in a concrete version. Okay, so that is just something that I would recommend as a really great tip. Template arguments. So these are called template arguments right here. So there could be more than one argument. It's in fact a list of arguments. So we can think about, for example, some kind of fixed size buffer, which is of value type like we use in our example. There is some sort of size. And look, the second argument here, the second template argument, says that this is a non-class argument, and it becomes a constant. So let me explain to you what this is. This type of syntax would allow us to specify a hard-coded constant of some kind to provide an integer constant or some other data type constant into the definition of our template class. Look, we have this container size, and I think it should be this container will become much more flexible if not this silly static constant integer defined as some kind of arbitrary number, but instead it would be really desirable if the user could specify and tell us what size of the container they want. Okay, so that's our next stage, and I think we're going to try to explore new modifications to the code by removing this hard coding size out of the definition of the class, of this template class, and making it instead a parameter, like add this to this parameter list.